let's first start. You've already read this. Start by coming up with a variable. It's a good idea to look at the question or the sentence with the question mark to figure out what you want to call your variable. So, for instance, the question mark here, and this sentence starts with how many more miles. So that usually gives us a clue of what we're trying to figure out. So if we're trying to find out how many more miles, it's a good idea to define our variable as m, which stands for miles. I'm going to show you a format for coming up with equations. You don't have to use, but it's something that visually sometimes makes sense. You're not sure, and it works on very basic, simple problems like this one. But as you go up to more difficult, it still works. So it's good to practice on easy problems. Like we know this whole distance from this starting point to this ending point is 350 miles, right? And we know we've already driven 90 miles, right? So the distance we have left from here, wherever that is, all the way to the end point we're trying to get to, that's our variable. That's m. That's how far it is to get from 90 miles to get to the total 350. And what we do is we figure that, well, these two smaller lines, they add up to equal the bigger part. So when you want to write an equation, you can say this. You can say, well, these two smaller pieces, which are 90 plus m, should add up to this total length. From here to here, we know is 350. So that should equal 350. Just like that. And there's your equation. Now, if you put m plus 90 or something like that, that's just fine. Someone else might have gone ahead and started solving this in their head already. And they might have written this. M equals 350 minus 90. That's still an equation because it has an equal sign. So as long as this has an equal sign, at this point in your answer, and you can solve it, it's probably going to be correct. Of course, m will end up equal 260 miles. Yeah. So it's not really the difficulty that we're focusing on. It's, here's this format for solving some word problems that involve equations. Make sure you call your variable something related to the problem. Miles we're looking for. Use m. And how to write your equation and solve it. And that there might be more than one way. One person might write it this way, 90 plus m equals 350. Someone else could write m plus 90 is 350. Someone else could write m equals 350 minus 90. Different correct ways of doing it. Okay. Now, write a sentence explaining everything. This is probably the most important part. Can you take this and actually explain it in words? Using proper grammar, proper punctuation, all that stuff. So you could say something like, let's see here. The trip is 350 miles. We drove 90 miles, right? That's just restating the question basically, what it said. It said we have a trip that's 350 miles, we've already drove 90 miles. So the first part is kind of like restating the question, and the second part is your answer. Right? You say, and there is what? How many miles left? Yeah, 260 miles left to go. Left to drive or remaining. I mean, you can use any sort of verbiage that conveys that idea that the whole trip is 350. We've already got 90, and we got 260 miles left. And you can say that, 1,000 different ways, and they're all correct as long as we have all the information all the key information that is in the question. Usually there's numbers in the question, 350, 90, and then our answer, 260. They should all be in the sentence explaining it all. It should include all that information. Right. Go ahead and let's do number 2. Let you guys help me out a little bit more. Start by reading it. What do you think we should call the variable? What are we trying to figure out? How much of what? How much money? So what's a good variable for money? Is that M or D, or just depends on, yeah. So you can choose whatever variable you want, but just have it make some sort of sense, some sort of relationship to the question. Like I personally like using D for dollars, but you can use M for money. Dollars is a little more specific because it tells us the units. As you guys saw yesterday, there's more different types of currency than U.S. dollars, right? There's the kunas that we did yesterday in the front, the euros and things like that. So this is a little more specific. I'm going to use my little chart here. I know we started raising money here, and this is where we ended up. We ended up with what we want to get, 175 total. And we got so far 100 and let's say 20. From here to here would be 120. And we need to know how much to get from here to the end, right? That's what our variable is, D. Can you write an equation with that information? Go ahead and do that and solve it. Either below it or to the right of it. Write the equation and solve it. So one above, remember I added the 2 top. 90 and the M added together and equal the bottom. So it would be the same idea here. The 2 top add up because of the smaller lines. They add up to equal the length of the bigger line. Good. 1 plus D is 175. Solve that. One step. And go ahead and write a summary of your answer. I leave it for you guys to write a summary that includes information from the beginning, 175, 120, and then your answer as well. Should all be in your summary. Let's take a number 3 and see how is this a little different. So what are we trying to figure out? Yeah, cost, right? So that'd be a good variable to have, cost. I'm going to be a little more specific. I'm going to say of 1 ticket. Because there's 2 people, so we were talking about the cost of both tickets or the cost of 1 ticket. If we just say cost, it's a little ambiguous. I'll put the cost of 1 ticket. All right, so I'm going to write, I know the total cost, right, comes out to, what is it, $19.90. And how many things were purchased? 4. 4. We got the 3, yeah, we got the frozen orders 1, we got 1 ticket, and then the second ticket. So 3 things that were purchased. So we got 3 different spots here. We got cost of, let's say, the frozen yogurt, which was $5.50. We got the cost of the first ticket, which we said is C. I'm going to call that C. And then we have a cost of another ticket. And they're the same cost, right? Again. Okay. Same idea is that all these smaller parts add up to the bigger part below. So we can say that 550 plus C, three smaller parts, should add to the $19.90. Okay. And there's an equation for you. And of course, we have variables on the same side here, 2C. All right, so we can simplify that to 2C. So we got 5.5 plus 2C equals 19.9. Now you notice for the purpose of solving the equation, we don't really need the 5.50 and the 19.90. So I just left those off on the next step because they're not relevant to actually solving. We don't need them there. Okay. Go ahead and solve. So right now we're taking off, well, how much do the two tickets cost? 2C, that's the cost of 2 tickets. We're taking off the cost of the frozen yogurt right now. So $19.90 minus 550 will give us 14.4. So the cost of 2 tickets is $14.40. So the cost of 1 ticket, divide both sides by 2, cost of 1 ticket, $7.20. So again, go ahead and write a summary using all the information from the entire problem. We know that cost $19.90 total, frozen yogurt was $5.50, and we found out the cost of the ticket, or 1 ticket, was $7.20. Put it all together. Give you a second to do that. Number 4. James got 2 job offers. Offers of 2 companies. One of them's offering $28,000 to start for the range of $3,000 a year, and the other is starting at $36,000. Considerably more to start off with first year, but the raises are smaller at only $2,000. So the first thing we want to recognize is that at some point, one company is going to be, well, at the beginning, one company is making more money. Like at the beginning, the second company does pay more. I mean, it starts at $36,000. That's $8,000 more than here. So at the beginning, yeah, the second one pays a lot more. But at some point, since this one has bigger raises, the first company will make more money. The question is, well, at what point? After how many years will that take for this first company to start making more money than that second company? Which is a good question you guys are probably asking yourself when you're looking for careers. Is that, well, this one starts with more money, but this one in the end will end up making more money if I stay there a long time. So you think about, will I stay here that long, or am I going to be here just for 5 years? And makes a difference on maybe what company you choose to work for. All right, so let's define a variable. What are we trying to figure out? What's a good variable here? Find the question mark. Yeah, in how many years? How many years, right? That's what we're trying to find. Why? Years. Others would maybe opt for T for time. That would be fine too. As long as you got something that you're going to use in your equation, figure it out ahead of time. All right. Now, we got 28,000. Okay, let's write this out. So we want to know when these things are equal, right? So one company is going to pay, starting off, it's going to pay $28,000. Right? And then from there to the end, we know it's going to be $3,000 each year. Now, each year is multiplication times y. All right, so we can call this 3,000 y. So after the first year, y is 0, so it's just 28,000. After the first year, y is 1. 3,000 times 1 would be 3,000. 3,000 plus 28 would give us 33. So we can calculate how much money they're making each year. All right. And then we got the one on the bottom here, the second company. It started off with 36. I'm going to do this one. It's 36, so it's a little bit more than 28,000, so I've made it bigger over here. But then the raises are only 2,000 per year, 2,000 Y. So the key piece of information you need for here is that the 3,000 each year is the same as 3,000 times Y, and $2,000 each year is 2,000 Y. Because that's what changes, that's what moves, that's what goes up. This 28,000 doesn't change. That's just what you make. It's not like you get another 28,000 next year. Right? It just goes up by a little bit each year. All right, so write an equation. Remember the bottom and the top are equal to each other. So these two smaller ones, 28,000 plus 3,000 Y, should add up to the two bottom ones, 36,000. Try to squeeze it in here, plus 2,000 Y. There we go, plus 2,000 Y. And we know how to solve these, right? Variables on both sides. So I can start by maybe subtracting the 2,000 Y on both sides. And subtracting the 28,000 on both sides. Doing both sets of algebra at the same time. That equals 0. That equals 0. So we have 3,000 Y, 3,000 a year minus 2,000 a year, 1,000. 36,000 minus 28,000 would be 8,000. There we go, and we know the rest how to divide by 1,000 on both sides. So Y equals 8. 8 years. So it turns out, if you're going to work less than 8 years, yeah, the second one is better because it pays more and you'll make more money there. If you're going to stay there over 8 years, yeah, that first company eventually will be making more money after 8 years, though. Just asking yourself, which one would be better? How long am I going to stay at this job? And you might know which one to pick. If it's going to be 8 years exactly, then you can pick either one, make the same amount of money, and then think about maybe some other things besides money and why you want to work one place over the other. Right. So write your conclusion there using all the information, and you should be able to use the front 4 to help you with that. Okay? And we'll see you tomorrow on a short Wednesday.